This video is about review for polynomial functions, calculator-based. Number 6. A. Let p of x equals 2x to the fourth power minus 15x to the third power plus ax squared plus bx plus c, where a, b, c are all real numbers. X minus 5 is a factor of p of x. Find a relationship between a, b, and c. Since x minus 5 is a factor of p of x, which means p of 5 equals 0. So we plug in x equals 5 to the polynomial function. 2 times 5 to the fourth power minus 15, 5 to the third power plus a times 5 squared plus b times 5 plus c equals 0. We put this into calculator. You will negative 625 plus 25a plus 5b plus c equals 0. Add 625 both sides, 25a plus 5b plus c equals 625. The relationship between a, b, and c will be 25a plus 5b plus c equals 625. Let's go to b. Given that x minus 5 squared is a factor of p of x and that a equals 2, find the value of b and c. X minus 5 squared is a factor, which means we have 2 roots, both equal 5. We will do the synthetic division by using these 2 roots. We are given this a equals 2, so 2x squared here. We have 2 negative 15, 2 b, c. Drop down these 2, multiply 10, negative 5, negative 25, adding negative 23. Negative 23 times 5, negative 115, adding b minus 115. Then multiply 5b. 5 times negative 115 will be negative 575. Add these two, 5b plus c minus 575. Since this is the remainder and 5 is the root, therefore this remainder equals 0. Then keep doing this synthetic division. 2, 10, 5, 25, 2, 10, adding b minus 105. This is a remainder. For this remainder, we set up equals 0. Then we solve b equals 105. Then we plug in here. 5 times 105 plus c minus 575 equals 0. We get c equals 575 minus 525. C equals 50. So the solution to b equals 105 and c equals 50. Let's go to number 7. Given that x squared minus 4x plus 3 is a factor of f of x equals x to the third power plus a minus 4x squared plus 3 minus 4ax plus 3, where a is a real constant, find the value of a. Since x squared minus 4x plus 3 is a factor, we will get the roots for this factor. X minus 1, x minus 3 equals 0. X1 equals 1, x2 equals 3, which means f of 1 equals 0 and f of 3 equals 0. For f of 1 equals 1 third power plus a minus 4 1 squared plus 3 minus 4a times 1 plus 3 equals 0. 1 plus a minus 4 plus 3 minus 4a plus 3 equals 0. Combine like terms, negative 3a plus 3 equals 0. Then we will get negative 3a equals negative 3. A equals 1. You can use this equation. You will get the same answer. Let's go to number 8. Consider the polynomial p of z equals z to the fourth power minus 6z to the third power minus 2z squared plus 58z minus 51. Z is complex numbers. Express p of z in the form z squared plus az plus b times z squared plus cz plus d, where a, b, c, d are real numbers. For a, since this is a calculator based, we need to put this polynomial function into calculator to get the zeros. So we put into graphing calculator, change z into x to the fourth power minus 6x to the third power minus 2x squared plus 58x minus 51. Then graph. We will get zeros. X equals 1 and x equals negative 3. By graphing, we figure out z1 equals 1, z2 equals negative 3. Since we want to express p of z in the form of this, we will change the roots into factor form. That is z minus 1 times z plus 3. For you, we will get z squared plus 2z minus 3. We need to figure out this part. We can use synthetic division. 1. Root in the corner, no missing power. 1, negative 6, negative 2, 58, negative 51. 1, multiply. 1, negative 5. Negative 5, adding negative 7. Negative 7, 51. Then 51, we get 0. Keep doing synthetic division using the second root, negative 3, 1, negative 3, negative 8, positive 24, positive 17, negative 51, 0. Let's check the degree. Z to the fourth power, z to the third power, z squared, z plus 17. In other words, z squared minus 8z plus 17 will be the factor. So we can write down the solution for A. That equals z squared plus 2z minus 3 times z squared minus 8z plus 17. Let's go to B. Sketch the graph of y equals x to the fourth power minus 6x to the third power minus 2x squared plus 58x minus 51, clearly stating the coordinates of any maximum, minimum points and intersections with the axis. We already put the function into y1, then graph. We need to change the window, negative 100, 100, scale 100 divided by 10 is 10, graph. We still cannot say this minimum value, but this window shows clearly the shape of the graph. This time for y minimum, let's turn it into negative 200. Maximum 100, you don't have to change. For the scale, let's turn it into 20. Then graph. We need to figure out this minimum value, maximum value, and minimum value. We already figured out the zeros, negative 3, 1. For the y-intercept, go to trace. We put 0, enter, negative 51. For this minimum, second trace, go to 3. Move the arrow to the left side of this minimum point. Enter. Then move to the right side of this minimum point. Enter. Enter. The minimum point is negative 1.62, negative 118 as a 3-sig fix. We need to figure out this maximum point. Second trace. Maximum, that's 4. We know here is 1, so let's use 1. Then move to the right side for that maximum point. Enter. The coordinates for this maximum point is 2.4, 26.9. Keep doing. Second trace. Minimum point. Left bound. Right bound. Enter. Minimum point is 3.72, 19.7. Since we get all the information for this graph, let's go back to the graphing paper to set up the coordinate plane. For this graphing paper, we will set up the coordinate plane. We will label this is x-axis, y-axis, origin. Let's do negative 1, negative 2, negative 3. This is 1, 2, 3, 4. For the y-axis, we know the minimum point is negative 118. Let's do negative 25, negative 50, negative 75, negative 100, negative 125, 25, 50. For minimum point is negative 1.62, negative 118. For x-intercept, negative 3, 1. For y-intercept, negative 51. For this local maximum point, 2.40, 26.9. Estimate over here. And for this minimum point is 3.72, 19.7. That's estimate over here. Then we can sketch the graph by connecting all these key points. Let's go to C. Hence or otherwise, state the condition on K. K is all real numbers, such that all roots of the equation P of Z equals K are real. All roots, since for this polynomial function, the highest exponents is 4. All roots, which means there are 4 roots. These 4 roots are real, which means y equals k, this horizontal line, intersect the graph for 4 intersections. Only when the graph between this maximum point and this minimum point, then when we draw a horizontal line, it will be 4 intersections. 1, 2, 3, 4. From calculator, we already figured out the y-coordinate of this local maximum, 26.9. The y-coordinate of this minimum point, 19.7. When k greater than 19.7, less than 26.9, all the roots of equation P of Z equals K are real.